we'll now do a proof. We want to prove that the limit as x goes to 2 of 3x plus 7 is equal to 13. That means that we want to zoom in to 1 over infinity and get it correct. All right, so what that means is that we will use the definition. The absolute value of f of x minus L is less than epsilon whenever x minus a is less than delta. That's the last part. Remember, it says that must satisfy, or that satisfies this condition. And the idea is, all the time in your assignments, I gave you epsilon values, and then you would find deltas, correct? So there's 2 steps to your proof. Now, you guys, don't exude your mathematical knowledge over the process at this point. This is the way you have to set up the proofs. If you want to argue about it, speak with my my real analysis instructor in college who had a PhD in mathematics and a PhD in English. Okay, this is the way you have to set it up. It's a 2-part. You first state the following: find an appropriate delta. And what that means is make the left look like the right. Now, that's not something you actually write during the proof. Does everybody understand that? That's just my hint to you. And so here's what I mean by make the left look like the right. We're going to use our definition here. Absolute value of, what is f of x in this problem? 3x plus 7 minus L. What is L? 13 is less than epsilon. Whenever x minus a, what is a in this problem? We okay with that? Any questions how I came up with any of those values? Ask now. Okay, I want to make the left look like the right. Does this look really anything like that right now? So look closer. What can I factor out of this? Look closer now. Now what should I do? This looks like this, doesn't it? So we have now found an appropriate delta. Notice how before I was giving you a worksheet. And I was saying use the graph and solve for it, come up with the appropriate delta. Now, instead of using the actual function and everything, we just did it like this. And we decided that delta is going to be epsilon divided by 3. So it's easy. We just take whatever the epsilon value is and boom, divided by 3. That's our delta. That's what we're going to do. So I have made this choice. A, delta is equal to epsilon divided by 3. B, I'm going to make a statement that will help me in my next step. You don't have to do this, but I encourage you. It's going to help you in your thinking. And I'm going to take this right here, this x minus 2 is less than delta, but I'm going to multiply both sides by 3. Does everybody agree that if the absolute value of x minus 2 is less than delta, then 3 times the absolute value of x minus 2 is going to be less than 3 delta? Everybody okay with that? Okay, this is the groundwork. We have used this to be able to make our statement that delta is equal to epsilon over 3. So now the second part of the proof is show absolute value of f of x minus L is less than epsilon whenever x minus a is less than delta. I am going to make that statement right now. Okay? Watch. Absolute value of, what's the function? Minus I would like to say it's less than epsilon, but I don't know for sure that this is less than epsilon. So what I'm going to do is I'm going to use some of my previous work. This is the same as 3x minus 6, which is the same as 3 times x minus 2. Everybody pause. There are 3 crucial parts. The red part is right there. Have we already made that statement? Yes, it's right there. This is a second crucial part, the less than sign. And then the third crucial part is the epsilon. But I must connect those mathematically. Can I now insert the less than sign? We know that 3 times the absolute value of x minus 2 is less than what? 3 delta. So I have the red, I have the green, and now I just need the epsilon. Well, I don't know if 3 delta is equal to epsilon, but I know 3 times delta is equal to 3 times, what is delta? Epsilon divided by 3, which is epsilon. And that is the last part of this statement. So it says show this. And I've connected those 3 things together. Now I've connected them with a series of equal signs, but that's okay. Do you see how it's all tied together then? That's the balance. Okay? So let's do another example. And then you'll have work time the rest of the hour. First step, without looking at the other side, choose what? Choose appropriate delta. Do you remember what we wrote down? The absolute value of less than epsilon whenever. So let's write that down. Try to make the left look like the right. Absolute value of minus -5, so plus 5 is less than epsilon. And we have x minus x minus 4 is less than delta. I want to make that look like that. So I have 8 minus 2x. What should I factor out? -2, right? We factor negative out, the absolute value becomes positive. So this now looks like the right-hand side. But instead of a delta, I have, so therefore, I'll choose delta equal to epsilon over 2. I'd also like to make a statement that will help me in my proof. You know what statement that is? So my second step is show the absolute value of f of x minus L is less than epsilon whenever x minus a is less than delta. Help me out. 3 minus 2x plus 5 equals 8 minus 2x equals less than 2 delta, which is epsilon. We have actually pieced together all three of the necessary components of our proof. The function minus the limit is less than epsilon. And you got it. You have now just verified that that limit is truly exactly -5. Okay? And so this changes everything. The formal definition of the limit allowed us to develop certain areas of mathematics that before we couldn't, and really allowed calculus to formulate the way it is. Now that we can put this together, we'll then be able to talk about continuity, which will then bring us to derivatives and integrals, the heart of calculus. So it's a pretty big day. What you want to know is what do you have to do for an assignment. Here's your assignment. And 1 through 10 are very similar to the worksheet problems that you have, but they are not worded exactly the same. So my hint to you is 1 through 10, if you can interpret from what the problem is asking, if you can interpret, oh, they're talking about the limit as x goes to 1 of x squared minus 4 is -3. I mean, if you can interpret that, then you'll know where to go and say, oh, and they're saying epsilon is 0.01. If you can figure it out in that formation, then you know how to find delta. Problems 15, 17, and 18, those are like the proofs that we just laid out for you. Maybe you want to start with the proofs because that's familiar in your brain right now, and then move to the worksheet. But do not do this, folks. Don't leave any one of these problems undone for the test. This is crucial to your success on this test. And this can be the highest scoring test of the year for your class. It has that potential. But if you don't do this part, the test can be disastrous for you. So own this assignment. You have the rest of the time to work. Go.